Oscillatory motion was, first we spoke about periodic motion. Any motion that repeats itself after the interval called the period is called periodic motion. Periodic motion can be revolution, can be rotation, and a special class of motion that we were interested was on oscillatory motion. What's an oscillatory motion? A to and fro motion, also known as a vibratory motion. So vibratory is also periodic, oscillatory is also periodic, to and fro is also periodic. And then we also spoke a little bit about something that we'll study in grade 12, which is called simple harmonic motion, a special kind of oscillatory motion where the displacement is always in straight line, means very small displacement. You are not allowed to make curves like a string. Okay, na? So, and then when we spoke about oscillatory motion, we spoke about some facets of oscillatory motion. So we spoke about what we mean by a cycle. A cycle is one complete to and one complete fro. Then we spoke about something called amplitude, the maximum displacement from the central to either of the left or the right, called the extreme position. Then we spoke about something called time period, time taken to complete one cycle or one oscillation. Then we spoke about something called frequency. Frequency was all about how many oscillations in 1 second. ठीक है ना, ये हम पढ़ चुके थे. Okay. After we read this, we also read about what is wave. A wave is a periodic disturbance. Wave is a periodic disturbance in which the particles who are a part of the medium through which the wave is propagating. Now we'll later on study, every time you don't need a medium. So particles of the medium in which the wave is propagating do not travel along with the wave. They just oscillate about their mean position. However, the disturbance travels. Some of the examples we saw was the wave of coming across and the guillemot doing up and down. Then on a gym, you're using a rope and creating wave, whereas the ribbon just going up and down. Ripples in a water, put a leaf, the leaf stays there itself, and the ripples propagate. And the Mexican wave, where we saw, or whom did we say? Kathy and Adam or something like that. We gave names, okay? They stand at their places and go up and down. However, the wave keeps traveling. Our next story was, we also said that a wave is a pictorial representation of an oscillatory motion. A wave क्या है? अभी जो पढ़ रहे हैं बेटा, this is called wave mechanics. This will be there whether you are studying sound, whether you're studying vibration, whether you're studying light, whether you're studying electricity. So whatever terms you're going to study about wave, don't just throw them away because they will be necessary for you. And we are going to now marry wave, as I told you, wave is like pyar, lot of pyars. Now we are going to marry wave with oscillatory motion. क्या oscillatory motion में wave होता है कि नहीं, and the motion can be pictorially represented by wave. Today we'll see more facets about wave. ठीक है? So let me try. I thought over and then I thought over a better example for you. So let the example be something like this. Okay? थोड़ा ऐसे सोचो, फिर इसको मिटाएंगे. This is a plotter. What is this? This is a plotter. It's like a pen plotter. Have you seen ECGs and other things? It's a plotter. This is a plotter. And this plotter is able to oscillate this way and this way. समझ में आ रहा है? ये प्लॉटर ऐसा किंक करते रहता है. ठीक है, समझ में आया आपको? ठीक है. Now what we do, हम लोग ये जो दोनों साइड आए ना, these are nothing but my amplitudes. Don't you think? These are my amplitudes. These are my amplitudes. And I would take this as this is my central position. समझ में आया? This is my central position. So I say that it goes to, if this is an amplitude on the positive direction of say plus A, this is negative A. ऐसे ऐसे जाना कर रहा है, right? And here, this is the interesting part now. Okay. You need some imagination here. This is a kitchen tissue roll. किचन का टिश्यू पेपर का रोल होता है ना, इट्स अ किचन टिश्यू रोल. नाउ यू नीड इमेजिनेशन. वी हैव स्टार्टेड टू मेक, दिस इज आवर प्लॉटर. ये हमारा प्लॉटर है. दिस इज माय, अरे this is my plotter, right? I have switched on the switch and the plotter is now going this way, this way, this way, this way, right? Have you understand? And in the same time the paper is also feeding downwards. ऐसे ऐसे कर रहा है और पेपर भी खींचा जा रहा है. Are you understanding? Otherwise if the paper was here, the plotter will only plot here, catch करेगा ना. तो हम क्या कर रहे हैं, पेपर को फीड दे रहे हैं. पेपर का फीड कैसा है? पेपर फीड इज समथिंग लाइक, से ये जो पेपर का रोल है ना, ये ऐसे आ रहा है. अरे व्हाई इज इट सो येलो फैसिनेटेड? आई मीन, ओके, 1 minute. So this paper is coming in this direction, okay, and let me see that the paper is continuing from here. Understood now? So there's a roll here and the roll is being pulled down as the plotter keeps on moving. नीचे जा रहा है. So ये नीचे जा रहा है, ठीक है. तो ये नीचे जाएगा तो आपको, अभी आप सोचो, now your imagination is required. Don't you think the plotter will plot exactly like this? This portion has gone away, new portion. Imagine there is a motion which is like this and the paper is being pulled. Seismograph. But this is what we are saying, that any oscillatory motion, this is oscillatory motion, and we are saying that the displacements are in straight line, okay, and the displacement ऐसे करते रहेगा और पेपर को खींचते रहो साथ साथ. If you are unable to understand, let's understand like this. Suppose this is your thing which is oscillating up and down out here, right? It is oscillating up and down here, and then say this is, so this is going to plot in what manner? ऐसे ऐसे plot करेगा. The other day we had told this plotter is going to move at this position, but by then time has also passed away, so it will not be here. The plotter was here, now the plotter will be here. Then the plotter moves to this position, so it's gone here. Then the plotter moves maximum here. Time is running. Then again the plotter comes back here, so here again plotter comes back here, plotter comes here, here. Now plotter goes below here. ये है oscillatory motion का wave motion. Is this understood? Any oscillatory motion will always create a wave pattern. Now I erase this diagram and I try to make the proper wave diagram, okay? और wave के मुताबिक समझते हैं इस चीज को. आओ, because we are having time, so let's understand everything by detail. So let's say, let's create one wave pattern. And now you're going to study only wave. So this is my positive amplitude and this is my negative amplitude. This is plus A, this is minus A, this is 0, right? And let this one be now plotted against time. First time I'm plotting this against time. ठीक है, ये टाइम के अगेंस्ट में प्लॉटेड है और इसको थोड़ा सा छोटा करते हैं. So let's make it a little bit smaller, keep it here and make one more copy of it and bring that down. ठीक है. Now in this one I am keeping it as, this one I am measuring it as distance. Same thing, same wave को पढ़ेंगे. हालांकि better होएगा. 1 minute, huh? Not now. Then our drawings will be proper. Give me a minute. Let me erase this part. Okay, let this be erased. Okay. This is your wave pattern. अब हमारा wave कैसा रहता है? Our wave would be particle goes up, the simplest form of wave. समझ में आया आपको? ठीक है, ये आपका पार्टिकल जीरो पोजीशन से हुआ, अरे आप जा रहा है, अप एंड डाउन करके जा रहा है. नाउ लेट मी मेक ए क्लोन. अब इसका क्लोन बनाते हैं और इसको नीचे ले आते हैं. Right. And here, instead of doing it in time, this particular one I am doing in displacement. This one I am doing in displacement. Okay, the same wave. So this shows me how the wave is propagating with respect to time. This shows me how much distance the wave is traveling. Are we clear all about? Okay. Now we will map each and everything that we saw in the oscillatory motion. Number one, we need to first understand how amplitude is seen in the wave. Amplitude. Amplitude क्या था? अगर आप भूलने की कोशिश करो, amplitude was, okay, this was my pendulum and this is amplitude as well as this is amplitude. Okay, if you take this as plus A, this is minus A. So here amplitude means this one is amplitude. This is plus A and this is minus A. ये सब समझिए. This is amplitude. Understood? I started from here. Say I started from here. Okay. Now we'll obey our graph. So I started from here. Say this be position 1. It goes this side and comes back here, half cycle. At 2 it makes half cycle. Again goes here and comes back here, that is 3. It makes one full cycle. If you see from this side, then it is 1 2 1 fro. But I'll see it from center because the graph is starting from center. It makes easier to understand. So from here to here and back here is what? Half cycle. And then again going from here to here is another half cycle. So in my graph, if this is showing me 2, then this shows me fro. समझ में आया? 1 2 and 1 fro is known as, it is known as one cycle. This is known as, let's take the graph here. Okay, this one and right. So out here, this will be known as my, from here to here is known as one cycle. One cycle. Clear? एक साइकिल, एक ऊपर. ओ ये ज्यादा हो गया. करेक्ट. Actually ना, ये sometimes this doesn't come immediately with you. He is correct. So and this undo will not work. Let me see. He is correct. Okay. The half cycle is at this position. One cycle. ठीक है? Now this is my this is one cycle. One cycle consists of 1 2 and 1 fro. ठीक है? ये जो 2 वाला है जो ऊपर में जाता है ना, this in wave is called a crest. And the one which goes down is called a trough. These things should be very clear with you, huh? Crest and a trough. So if I represent one cycle can be represented by one crest plus one trough. This is the easiest way to understand. Easiest way to understand one cycle. Right? I should have not written the cycle here. Cycle is actually shown when you are measuring it on the time axis. So this is one cycle. One cycle. All right? And deliberately I am removing this part. इसको देखेंगे आगे. इसको क्या बोलते हैं? Okay, this is one cycle which is equal to one crest plus one trough. Crest and trough is the wave language. Have you understood? This is one cycle. Now, say suppose to complete this one cycle, the time here is t. Then t will be known as my what? Time period. This is how you read time period from the wave chart. If t was the time here, say this was 2 seconds. एक cycle करने में कितना लगा? 2 seconds लगा. So 2 seconds is my time period. Understood? Now another question comes. If the wave is also the wave is a disturbance which is also traveling, how much distance did the wave move in one time period? In one time period, how much distance did the wave is moving? Particles are not moving. Particles are oscillating at their own place. The wave is moving. How much distance did the wave move in one time period? That is known as wavelength. And this is denoted by the Greek letter lambda. इसको हम क्या बोलते हैं? Lambda. LAMBDA. Greek letter. This shows your wavelength. Wavelength is the distance traveled by the wave in one time period. और one complete cycle का जो length होगा, तो wavelength का unit क्या होगा? Wavelength will always be measured in meters. Wavelength will always be measured in meters. Time period will always be measured in seconds. यहाँ तक बोलो. Anyone has any query at this stage? I am trying to draw the wave under two axes. One is time and one is displacement. Time means how is the wave propagating with respect to time? How much distance is the wave propagating? Is the same wave. Clear हुआ इतना? हाँ, देखेंगे अभी पॉजिटिव नहीं. अब ऐसा कुछ नहीं है कि one cycle is always one crest and one trough. साइकिल कहीं से भी हो सकता है. जहां से शुरू कर रहे हो लौट के वहीं आना है. तो अब वेव में वो देखेंगे. अब दैट्स आवर नेक्स्ट टॉपिक एंड देन विल सी वेदर यू स्टिल हैव दैट क्वेश्चन और नॉट. ठीक है. नाउ वन थिंग वी हैव अंडरस्टूड that one wavelength represents one cycle. Now the question arises, sir, is the cycle always one crest and one trough? Not exactly. Who has asked you to pull till here? I'll pull till here. It goes, comes back, again comes here. It's still one cycle. So now pay utmost attention at this place. Let me pick a point out here on the wave. What is this point? Try to identify the point properly. It is the point which is on the upward phase of the crest, right? The next immediate such a similar point on the wave will also be one wavelength. Is this the similar point? No, it is the point on the crest which is going down. I need a point on crest which is also going up. ये कैसा है? ये ऊपर जा रहा है ना. आपको similar point, वो point यहाँ है. So if someone measures from here to here, this is also same wavelength lambda and one cycle. और अगर मैं यहां तक मेजर कर लूं, ये हो जाएगा 2 lambda, double the wavelength. Is this clear? Such points are called points in same phase. Points in same phase. 2 points are said to be in the same phase if 2 immediate points in the same phase will constitute 2 consecutive points on the same phase constitute one cycle or one wavelength. Does that mean that, sir, if you name this point as 1, name this point as 2 and name this point as 3, क्या ये तीनों phase में नहीं है? बिल्कुल phase में है. पर wavelength measure करने के लिए nearest 2 phase के बीच में ही हम measure करेंगे. यहां से यहां मेजर करने का डबल वेवलेंथ हो जाएगा. इसको समझते हैं. परेड में सामने का सोल्जर, पीछे का सोल्जर, उसके पीछे और एक सोल्जर है. सेम फेज मतलब सबके हाथ एक साथ उठ रहे हैं ना, तो सबका ये कपलिंग एक ही साथ ऊपर जा रहा है. सेम फेज तभी परेड अच्छा लगेगा देखने में. वेव पीरियोडिक मोशन है ना. परेड इज ऑल्सो पीरियोडिक मोशन. वहीं एक अतरंगी सोल्जर अगर उल्टा पुल्टा कर रहा है, वी विल से व्हाट, ही इज आउट ऑफ फेज. ही इज आउट ऑफ फेज. Are you getting the point? Okay, if you understand wave mechanics, half of sound will be clear. So we have understood what is. So what all things did we understand now today? Fresh हम लोगों ने क्या क्या देखा? Fresh. Let me just write down and you tell me if you have understood or not. We saw Sorry. We saw wave, okay, and when we saw wave, we understood one, how to show amplitude on the wave, okay, then how to understand what is a crest and what is a trough on the wave. Then we also understood how to understand what is a wavelength. The wavelength is always measured with corresponding to x. This is measured in meters. And then we also understood how to see a cycle. Cycle में ये हमेशा time के साथ हम देखते हैं. And 5, we also understood how to have a look at time period. And then we also understood a concept called phase. 2 points in a wave are said to be on the same phase if they have the same sense of motion in the wave. Okay, दोनों ऊपर जा रहे हैं तो दोनों ऊपर जा. ये समझोगे तो क्लास 11 में ट्रिगोनोमेट्रिक फंक्शंस भी अच्छे से समझोगे. All are interconnected. This is nothing but a sine wave that you are. This, if you, this in higher classes is nothing but y equal to sine x. This is a sine graph, and sine x's maximum value is +1, -1. So a sine graph pulsates between +1 and -1. This will be very necessary in current also. You will study this, so understand these things. Any questions out here so far? Right, no questions. Okay, say suppose this t's value was equal to 1 second. Say 1 second. So now the question arises, how many cycles in 1 second? 1 cycle. This particular wave is having a frequency of 1 hertz or 1 cps or 1 second minus 1, because I know that time period is inverse of frequency.
So what is 1 CPS?
Cycles per second. Cycles per second is called CPS. We'll use hertz more. Same thing, cycles per second or second minus 1. So have you understood between frequency? Frequency होने से हमेशा time के साथ देखना है. How many cycles in 1 second? And say for example, now the graph is getting dirtier and dirtier, but we'll still go on this. Say this is 1 cycle, this is another cycle. Say for example, at this point, it was, say, 1 second. Say again, say at this point it was 1 second. Now what is the frequency? In 1 second, 2 is the frequency. 2 cycle मार लिए हो. 0 होने के लिए यहाँ पे होना पड़ेगा, 0.5 होने के लिए यहाँ पे होना पड़ेगा. मतलब 1 सेकंड में हाफ हुआ, half cycle. 2 cycles have been done. Do you understand? Okay, very good. Can I rub this? Okay. So few things, few formulas that we have encountered so far is time period, which is measured in second, is always given as 1 upon frequency, and frequency is measured in hertz. This is the only formula that you have come across. And you came across another mathematical term called wavelength, which is denoted by lambda. Okay, higher classes में frequency का एक और denotion भी रहता है. Frequency is also denoted by this, which is called nu, the Greek letter. You keep it as f, it becomes easier for you. Okay, so this is frequency. Are we fine now? Okay, now let's see two waves. Okay, both are on time axis. Okay, and say this is, so this wave is showing a pattern like this, and this is t here, this is t here also, right? I have another wave what is the difference between these two? एम्पलीट्यूड से कोई लेना देना ही है, दोनों का एम्पलीट्यूड बराबर है. फ्रीक्वेंसी, इसका फ्रीक्वेंसी कम है. in t time it is completing 1 cycle, in t time it is completing 2 cycles. This is double the frequency, this is double the frequency. And if the amplitudes are same, अभी थोड़ा थोड़ा साउंड के बेसिक्स को समझेंगे, फिर किताब को चाटेंगे. If the amplitudes are same, say this is also plus A, this is minus A, this is also plus A, this is also minus A. You know, in real life, what you're trying to do, you are playing two songs, the same song, sung by a boy, sung by a girl, same volume, same volume. Amplitude is same. Amplitude will actually tell you about, जहां हम amplitude देखेंगे ना, ये सब पढ़ेंगे आगे, लेकिन इसका ब्रीफ ज्ञान नहीं होने से आप समझोगे नहीं. Amplitude is directly proportional to loudness. Rather, loudness is directly proportional to amplitude. So here, instead of writing this directly proportional, at this level, I'll tell you, amplitude is a measure of loudness. In the case of light, can you tell me what light can also go through a wave? What will amplitude represent? Brightness, intensity. Intensity. Light के केस में amplitude आपको intensity देगा. Have you understood? It will give you intensity. So this is a sound which is now all of you are, whoever you all play a piano, आप piano बजाते हो तो you have a key called middle C, है ना? Yes. Middle C. तो मिडिल सी पर जाने से सी स्केल का मिडिल सी से दैट इज योर डो आप स्टार्ट करते हो वहां से, ठीक है. आप मिडिल स्केल के मिडिल सी से लेके आगे जाके एक और सी आएगा आपको, another C will come. This C and this C सुर में एक ही है. अगर ये सा है तो ये भी सा है, ये हायर फ्रीक्वेंसी है. So whatever is the frequency of middle C, this one will be just double that frequency. And before starting a song, when you sing a song for an orchestra or something, you have hired him as a guitarist. He played yesterday with somebody else, and today the singer is somebody else. That doesn't matter to him. All he will ask the singer is that on which scale are you singing the song, and he will say मैं तो बच्चा हूँ, मैं C scale में गाऊंगा. Very good. Who is your piano guy? So they say this fellow is my piano guy. Our friend Angad is the piano guy. Angad, can he sing on C scale? He will ask. Yes, he can sing on C scale. Angad को बोलेगा तुम अपना open E plug मार के रखो, the E chord, and he will just press his E chord and he will just blankly pluck his E chord. Nowadays you have got tuners digital. Digital tuners do not make you a good musician. If you are a good musician, you just throw the guitar to him and he should be able to tune it up. So he just plucks his E, ding dang, and he'll press the key on piano and then close your eyes. You should hear one sound. Once that one sound has happened, his guitar has got tuned to his piano, and the singer will sing on C scale, that he will take care. Rest on E, he can now tune up all the strings.
Like C to C, that is
one octave, because आठवां सुर हो जाता है, सात के बाद आठवां आ जाता है. That's one octave. So music also follows the same pattern. ठीक है. अब इसमें और थोड़ा इंटरेस्टिंग चीजें सुनेंगे. जब तक इंटरेस्ट नहीं आएगा मजा नहीं आएगा. So look, we are from a generation, we have seen transition of things. So in the year 2005, I was in Delhi and I had a car which was Maruti Suzuki ST. Okay. Those days, these cars used to come with factory fitted cassette players. Just see the story. This came with a factory fitted cassette player and it was of Kenwood. No aux port, nothing. So you just put the cassette and you listen to the music. Year is 2005. Brand new car in Delhi. That car I brought from Delhi to Hyderabad. I changed my job. I got into Infosys and all. And then in 2006, I went to US. And I bought Apple का पहला iPod खरीदा. हमें नहीं पता आपने iPod देखा है कि नहीं, iPod है. And that iPod was iPod Nano. Good thing, whatever songs you can load on the iPod, and just by pressing the button you can listen to that song. So you can create a wish list. Otherwise in cassette, वो वाला गाना. See, when we used to travel earlier, we used to have one carry bag of cassettes. वो वाला गाना लो, cassette लगाना पड़ता है आगे पीछे. Now the problem starts. How do you make the iPod talk to the cassette player? See how much of science is involved. Okay, the cassette player does not have any port. Like now you have got an aux port, nothing like that. So in US there was a cassette available. There was a cassette available which did not have any sort of what you call ribbon in it, any sort of tape in it. This cassette could be connected to the iPod. Okay, and the cassette is put into the cassette player. But this cassette costs high cost. इतना पैसा हम खर्च नहीं कर सकते. Means it is not making it worthy. Plus you don't get that cassette. what is the next option available with me? Because I was not on the money front, but the next option actually appeared to me of more khurafati. So I said I should try the next option. The next option was very interesting. The iPod is a device which is like this, right? And here you have your earphone jack and the charging jack is out here. There is a device available, it was available in Radio Shack. Radio Shack is the shop in US, okay? Sheldon को ऊपर young Sheldon देखोगे तो young Sheldon वाला, हाँ, Radio Shack, हाँ, तो Radio Shack में एक device मिलता है, and this is the iPod. This is nothing but a small radio transmitter. It's a radio transmitter. Now see the beauty. This radio transmitter can actually create FM channels. So I'm talking about 2006. We had Radio City 91, 92.5, 93. ये सब तो already booked था. These are the FM channels. So what I do, I plug it on my iPod and I select some vacant frequency 87.0. Now this is what this iPod is doing. It is transmitting a radio station across it at 87.0. And on the cassette player, I tune my cassette player to 87.0. This song starts playing on my car. I am very happy. But my hunger doesn't stop here. Then I bring my colleague and I say, भाई तू अपना गाड़ी मेरे गाड़ी के बाजू में लगा. And I tell him, तू भी 87.0 कर तो. Now he is also listening the song. And I have done this inside Infi campus bench में बैठे कोई project नहीं है. इसे क्या करना है? मैं लगाऊँ ना उसको. देखते हैं वो सुनता है कि नहीं. Then I understood that I also need a jam protection. Those are, see, that's how you learn things. Basically, this is frequency modulation. That is how you talk. In earlier wars in 65 and 71, you used to tap across the enemy wireless. The enemy is speaking on a medium wave. And they will not decode their frequency, not tell you their frequency. So if you match, stop, दुश्मन का line हमारे line पे है. बस उसकी आवाज सुनते रहो आप. आजकल हम encrypt कर देते हैं. You know, there is a layer of encryption. Whatever you're speaking has now been converted to all sound knowledge and this, and it starts propagating. During the Cold War period, Russia, see, one who has handled radio, he will understand the beauty of this chapter of sound. And unfortunately, you all have never seen the beauty of radio. Radio caise sunte hain. Now, like right now, if you are say now, US has got so much of what do you call embargo on Russia. Russian media not allowed, this not allowed, this not allowed. Still, I want to hear news from the Russian media. How can you hear? Radio. Radio does not need any internet or anything. Nothing is required in radio. Even if satellite fails, then your whole signal gone, Star TV or TV gone. Then internet fails, everything gone. Still you want to hear original. So Russia has also blocked all media channels. There are some British people in Russia. They want to hear original BBC news. Kaise sunenge? Radio. In fact, if you see the freedom movement, when Netaji Subhash Chandra Bose was home arrested by the British, I hope you know this.
Yeah.
Okay, he fled from his home in disguise, came to Bihar, took the frontier mail and took Bihar, and then Howrah Kalka mail, went till Lahore, and from Lahore all the way to Germany. And from Deutsche Radio, he first speaks. I'm Subhash speaking, and that takes the British into amazed कि कैसे एक आदमी चला जाता है. So रेडियो से आप कहीं भी बात कर सकते हैं और रेडियो की खासियत को भी आगे देखेंगे. So are we now clear on wavelength, frequency, time period? Now we still need to marry this. इसका भी एक formula चाहिए हमें. How to find out wavelength? This we will be requiring in our problems. Okay. Now we have something else called the speed of wave. This is at which the wave is traveling, the speed of wave. The speed of wave is denoted with the letter say C, right? And C is said to be the product of the frequency and the wavelength. This is a master formula. इसको याद रखिए. ये भी आपको जरूरत होगा. And to do problems in grade 9. The speed of a wave. So all these Tata Sky, Airtel that you are hearing from where? The great sun. Sun से क्या आ रहा है? Electromagnetic waves. And in electromagnetic waves, what do we have? गाड़ी, XUV, क्या है? In my range. So these are the radio waves and these are the microwaves. They are all coming at what speed? They are coming at the speed of light. 3 into 10 to the power 8. Whether it is gamma rays, X-rays, everyone is coming at the same speed. So if you know the frequency, you should be able to work out the wavelength. Now, this example might not stand proper with you. If you go at home today and you search the internet, आप विविध भारती ले लो या AIR, just take any station of Akashvani, All India Radio, and you say, what is the, in radio we have two signatures. One is called the wavelength, okay, and one is called the frequency. This is called the call sign of any radio station. How is the call sign? ये schools नहीं बताएगा, मजा नहीं आएगा आपको. Call sign कैसे होता है? Suppose you're transmitting from BBC. They'll say, good morning. This is the BBC World Service News broadcasting on 29.so meters medium wave and 11.566 megahertz on the short wave. ऐसे करके आपको पूरा, you have to announce. Everyone will announce. This is the All India Radio broadcasting on this and this wavelength and this frequency. Nowadays, if you can go to YouTube and you can say ABC Australian Broadcasting start sign. So they'll tell you this is the ABC, or the good channels in those days used to be, still today, BBC. Then you have VOA, Voice of America, Radio Beijing, Radio Ceylon, then Deutsche Radio, then All India Radio. ये सब आप देख सकते हैं. They'll tell you. Or the ABC, Australian Broadcasting Corporation, they'll say this is the wavelength and this is the frequency.
So they reserve it.
Yeah, that is reserved. Everyone has got a particular frequency. They reserve it. And that frequency, suppose I very well knew that I used to be in Assam, so around at 29.8 meters on the short wave BHG hota hai, still not know, I could catch the BBC. So every time you tune your radio to 29.8 on short wave, anywhere in the world you'll go to BBC only. And while BBC will transmit that, they'll say that on which frequency they are transmitting. So when this was taught to me in grade 9, I didn't have internet. But what I used to do, take the radio and take the scale, see the meters and see the frequency, और इन दोनों को multiply करो, आपका आंसर ये आना चाहिए. और आएगा ही आएगा. Tata Sky's wavelength will be there. If not Tata Sky, rather the channels like say Sony Live will have a wavelength, will have a frequency. Multiply these two, it should be. You will get the value as 2.999 into 10 to the power 8. ये previous batches को करके भी दिखाया था. You take All India Radio and you take All India Radio Delhi and you first say what is the wavelength? Band. What is the band? They'll tell you the band is so many meters and the frequency is so many megahertz or kilohertz. Multiply both those, you'll get the speed of light. Clear होता है? सारा दुनिया का communication इसी के ऊपर हो रहा है. ठीक है? So going a little bit more basics now. अब जब हमने wave के बारे में इतना कुछ सीख लिया है, so that when we come to our chapter, we should not fumble what is wavelength. We will define those at that places. But wavelength, wavelength means one complete cycle. Time period means time taken for one cycle. Frequency means in 1 second how many cycles. Can be 1, can be half, can be 0.75. And what is wavelength as a product of? Wavelength is the product of frequency into, no, speed of light is the product of wavelength into frequency. अब वेव के पैटर्न्स देखते हैं. व्हाट आर डिफरेंट टाइप ऑफ वेव्स? दो पैटर्न्स हम यूजुअली पढ़ते हैं. वन इज कॉल्ड मैकेनिकल वेव एंड अनदर इज कॉल्ड इलेक्ट्रोमैग्नेटिक वेव. This is one type of classification. These are all grade 9 stuff. Mechanical waves. What are mechanical waves? Those waves which always need a medium to travel. मीडियम नहीं तो वेव नहीं जा सकता है. तो हमारा चैप्टर है साउंड. तो साउंड यहाँ पे आ गया, वाटर वेव्स यहाँ पे आ गए, अर्थक्वेक यहाँ पे आ गया. इन सबको मीडियम चाहिए. नो मीडियम नो वेव. स्पेस में डू वी हैव एयर? नो. So sound does not travel. Grade 8 used to hear a question, why do astronauts use radio sets for communication? Because at space we do not have a medium, and sound is what? Sound is a mechanical wave. In fact, जब हम sound को पढ़ते हैं, you will further learn that sound is a pressure wave. Pressure बनाता है. So it's a mechanical wave. So if you are a mechanical wave, you need a medium to transmit. Medium नहीं, आप नहीं जा सकते.
So light is an electromagnetic.
Now, लाइट एंड रेडियोएक्टिव मत बोलो. लाइट ही सब कुछ है. Light is an electromagnetic. Light is the visible portion. Okay. This is the sun. The sun gives you something which is known as the electromagnetic spectrum. In this spectrum, we have got Gadi, X, UV, in my range. और ये बीच में जो थोड़ा सा है ना, इसी को आप लाइट देखते हो. Gamma rays, X rays, ultraviolet, infrared, micro, radio. This portion is light. So all these are electromagnetic waves. And they come from where? The sun. And the sun is far, far away from us. There is a lot of space in between which does not have any medium. So all of them are traveling and coming to us. How are they coming to us? Because they are electromagnetic waves. अब थोड़ा सा इलेक्ट्रोमैग्नेटिक वेव का कहानी भी देख लेते हैं, क्योंकि ये सब चैप्टर में नहीं है ना, बाद में बता नहीं पाऊंगा तो मजा नहीं आएगा. इलेक्ट्रोमैग्नेटिक वेव इज अ वेरी स्टाइलिश केस. यू विल रीड अबाउट इट इन ग्रेड 12. ओके, लेकिन पैटर्न देखो, मजा आ जाएगा. इसमें ना थोड़ा खराबी है कि 4 बार देने के बाद ये और नहीं चलता है. ओके, आई नीडेड दैट वेरी बैडली. 1 minute. Let's go back. Restart. Okay. Now let's see an electromagnetic wave. These are my 3 axes. Okay. I'm naming this as z-axis, this is say y-axis, and this is x-axis. Electromagnetic wave होता क्या है? An electromagnetic wave is a combination of 2 different waves. One is electrical and one is a magnetic. एक electrical wave है and one is a magnetic waves. Both the waves are traveling in what way? In perpendicular direction to each other. Now this needs a little bit of imagination. थोड़ा देखो कैसा है. So let me say the green one is or the blue one is representing electrical wave. Okay. एक magnetic wave रहेगा. ठीक है? Have you understood? And so I'm saying my electrical wave is traveling in which direction? X-axis. The magnetic will travel in an axis which is perpendicular to it. So I'm left with either Z or Y. तो मैं Y के साथ बनाता हूँ. हाँ. So the magnetic वाला कैसा रहेगा देखो. The magnetic one will be, it is on the Y-axis. So this is vibrating on the y-axis. Combination of both is called the electromagnetic wave. Electromagnetic wave is neither the blue one nor the yellow one. Both of them now will be vibrating in which direction? In the z direction. The electrical signal goes in one axis. The magnetic signal goes in one axis. And combination, the wave, which is a combination of both, goes perpendicular to both the axis. इसका बेस्ट एग्जांपल कुछ ऐसा है. मैग्नेटिक वाला इधर जा रहा है, देखो, समझ में आया? Right? And electrical is going like this. The wave travels like this. This is electromagnetic wave.
So it's like
Its propagation, no, its propagation is parallel to the axis which contains the magnetic wave. Tough subject, that's why you learn in grade 12. And also perpendicular to the electrical, also perpendicular to the, so what is the axis which is mutually perpendicular to both Z?
So it's like a
तो ये ऐसे जाता है. और ये इसकी और एक बड़ी खासियत चीज है, ये सेल्फ प्रोपोगेटिंग है. See, it does not have any medium. एक बार शुरू हुआ ना, वो आप पढ़ोगे बाद में, एक बार शुरू होगा, खत्म ही नहीं होगा. There's that property also. Whereas a sound wave is not like that. A sound wave always depends upon the intensity with which the wave was created. मैं जितना जोर से चिल्लाऊंगा उतना दूर तक ही जाएगा. After some time the intensity dies down. so the sound wave cannot travel anymore. If his ears are at a distance from me, which is far away till the wave cannot travel, I am speaking right now. Is anybody in N Tower able to hear me? No. The wave must have died down. इसे केस में ऐसा नहीं है. तो ये हम पढ़ेंगे आगे जाके ग्रेड 12 में, तो अभी दिमाग नहीं खाने. So what is an electromagnetic wave? An electromagnetic wave consists of two signals. One is an electrical wave and a mechanical wave, both perpendicular to each other, and propagation is always perpendicular to the both. ये आपको कोई पूछेगा नहीं. So our discussion comes, what is our way of seeing in grade 9 waves? In grade 9 we will have two distinguishing parameters for wave. One would be mechanical and one would be electromagnetic. So this is one question that you need to answer. What are mechanical waves? Mechanical waves are those waves which need a medium for propagation. Example, sound waves, water waves, earthquake waves, these are all mechanical waves. So this will be asked to you in definition. Have you understood what is mechanical wave? What are electromagnetic waves? Electromagnetic waves are those waves which do not need any medium for propagation at grade 9 level. Give an example of electromagnetic wave. The entire electromagnetic spectrum of the sun you can write. Gamma, X-rays, ultraviolet, infrared, light, radio waves, microwaves, these are all electromagnetic waves because they all originate from the sun spectrum. इसके अलावा और कोई electromagnetic wave है नहीं. That's why using the mobile is not good because you are having electromagnetic radiation coming onto you every time. Are you getting it? Okay. The classification that we will be more interested for in grade 9 would be another classification, and that is waves का एक और classification देखेंगे, longitudinal and transverse. अच्छा, दोनों के बीच फर्क समझने से पहले पिछला वाला फिर से देख लेते हैं. What did we study just now? Waves can be mechanical or can also be electromagnetic. This classification was based on the medium. Based on the necessity of a medium for propagation, waves can be classified into mechanical and electromagnetic. We are grade 9. What are we studying? Sound. So we are interested in mechanical wave. ठीक है, हम mechanical waves पे ही interested है. Or just for definition, this is at this level, this thing stops out here. Then second comes another classification. What are waves? Waves can be classified as longitudinal or transverse. This is depending upon, this is on the basis of direction of propagation of wave versus direction of vibration of medium particles. Medium particle or the wave. Yeah, इसको अभी और पढ़ने की जरूरत नहीं है, तो इस मोशन को मिटा देते हैं, इसकी और जरूरत. Let's understand this. Direction of propagation of wave. So let's make a wave. Sorry. Let's make one wave. This is our wave. Wave is going this side. Okay? If the particles of the medium vibrate perpendicular, particles are not going to move. Particles will only vibrate at their own position. That's what we learned in wave. If the particles vibrate perpendicular to this direction, for example, the Mickey on your car dashboard with a spring, ऐसे कर रहा है, is vibrating in which direction? Up and down. Don't you think? And which side is my wave going, beta? My wave is going in this direction. What is the angle? ऐसे wave को हम बोलेंगे transverse wave. Transverse wave. So if I have a hacksaw blade out here, how does the motion of the hacksaw blade? करके काट रहा है. Oscillatory motion? Yes. Periodic motion? Yes. Special name? Quick return mechanism. It's a quick return mechanism. जा रहा है. इसे wave से दिखा सकते हैं? बिल्कुल दिखा सकते हैं. Because if you put that kitchen tissue roll and start pulling it, the hexaplate will make a wave pattern on that. What type of wave is it? Transverse wave. Because the particles are vibrating at perpendicular to the direction of the motion. इसको हम क्या बोलते हैं? Transverse wave. Okay. Now, if my particle is vibrating, ऐसा vibrate कर रहा है, and wave is also going in this direction, then this is called a longitudinal wave. A wave in which the wave particles vibrate to and fro on the same direction as that of the propagation of the wave is called a longitudinal wave. This is known as a longitudinal wave. बोलो ये दो समझ में आया? नहीं आया तो फिर से बता सकता हूं. What is a transverse wave and mechanical and electromagnetic is gone. Now we are talking about transverse and longitudinal wave. What is our chapter? Sound. Sound is a mechanical wave in that classification, and sound is a longitudinal wave. So sir, light क्या है? Light is a transverse wave. Imagine light का particle कौन था? Electrical wave, magnetic wave. Both are perpendicular to each other, and the direction of propagation of the wave was perpendicular to both electrical as well as mechanical. ऐसे जा रहा था. Transverse wave. Okay, sir. You are giving two high funda examples. Can you give one example in which we can understand very simply what is longitudinal and what is transverse? Absolutely. Take a wall and buy a long spring, which is called a slinky. Spring को slinky बोलते हैं. And put Piyusha. She has no work with that spring. So she Piyusha को लगा दिया यहाँ पे spring के साथ. उसको बोला spring को ऐसा करते रहने का. So Piyusha is doing what? She has taken the spring and she's doing like this with the whole spring. What type of wave is she making? Transverse wave. Her motion is perpendicular to the direction. Direction आपको कैसा दिखेगा? Direction तो ऐसे जा रहा है wave. And again I told you to prove that it is always the wave which is moving. Tie one ribbon out here for your proof. The ribbon will always stay at the same place. But ribbon कभी ऊपर जाएगा, कभी नीचे आएगा, कभी ऊपर जाएगा, नीचे आएगा. See, what is the alternate motion of this particular wave? The alternate motion of this particular wave will be like this. Alternate motion मतलब समझे ना? कभी ऊपर जा रहा है तो कभी नीचे जाएगा. This is what is happening. So my red ribbon will go. My red ribbon will be कभी ऊपर जाएगा, कभी नीचे आएगा. समझ में आ गया? Now take the same slinky and put Piyusha again into job. फिर से काम दो उसको. क्या काम? आपका काम है slinky खींचना. Now Piyusha. Now she's having the same slinky. Slinky means what? A slinky is a loose, long spring. इसको हम क्या बोलते हैं? Slinky. Slinky. These things you should have at home. Object of interest for science. And I tell Piyusha now, Piyusha, अब slinky को ना अपनी तरफ खींचो और छोड़ो, अपनी तरफ खींचो और छोड़ो, अपनी तरफ खींचो और छोड़ो. So Piyusha जब ही करेगी ना उसको ऐसा पैटर्न आएगा. ऐसे जोन्स को पढ़ेंगे हम. बोलते हैं कंप्रेशन और ये बनेगा हमारा रेयरफैक्शन. ठीक है. इसमें तो ग्राफ समझ में इजी आ गया. ये क्रेस्ट है तो ये ट्रफ है. यहां भी बेटा ग्राफ, यहां भी वेव बनेगा. अगर कंप्रेशन में क्रेस्ट बन रहा है, रेयरफैक्शन में ट्रफ बनेगा. वेव तो बनेगा ही. वेव से आप बच नहीं सकते. Gives you an idea now. So what is sound wave? Sound wave is a longitudinal wave. Means sound travels in this direction. Please understand. Now your next question would be, sir, इसका alternate wave बनाइए. Alternate wave will be like this. At a time t, this was the position. The next time t dash, the position will be like this. मतलब समझ रहे हो? यहां पे जो बैठा है ना बैजू बावरा, कभी मैं कंप्रेशन, कभी मैं रेयरफैक्शन, कभी मैं कंप्रेशन, कभी मैं रेयरफैक्शन. It's like that. Don't think that anything is propagating. So how to understand? Sir, take the school bus and have how many? 10 kiddos. नर्सरी के बच्चों को ले लो, एकदम एकदम मेक देम सिट क्लोज टू ईच अदर, बॉडी टू बॉडी एकदम टच करके बैठा है, एंड यू बी द नॉटी गाय, और आप इसको किट 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 टिकलिंग करना शुरू करो, हंसेगा। और थोड़ी देर बाद क्या होगा, जैसे ये वाइब्रेट करेगा, आफ्टर सम टाइम यू विल सी दिस वन इज आल्सो वाइब्रेटिंग, द लास्ट वन इज आल्सो वाइब्रेटिंग। आर यू गेटिंग इट? Domino effect. Now the question arises, frequency depends on what is the frequency of their vibration? This fellow. Frequency always depends on the source. If this fellow reduces the tickling speed, they will also slowly become stable. ये अगर जोर से करेगा ये करता है। Is this a mechanical wave? Yes. Does it need a medium to travel? Yes, it needs a medium to travel. How do you prove it? इतने सारे बच्चों को गायब कर दो, पूरा वो यहां तक बच्चा से हा करेगा, ये सब चुप हो जाएगा। काट दिया ना आपने। कोविड में वी यूज्ड टू से ना, ब्रेक द चेन। सो इफ यू ब्रेक द चेन, break the chain. Understood? This is sound wave. With this much knowledge from next class, we will start the actual chapter of sound. So when we start sound wave next time, and I go for some examples, at that time, you may have the query, please ask it, but it should not be completely alien for you. हमको बुधनी का समझ में नहीं आ रहा है, वेव क्या है, वेव फ्रंट क्या है, और वेव फ्रंट तो आपने नहीं पढ़ा, वेव लेंथ क्या है, क्रेस्ट क्या है, ट्रफ क्या है, फेज क्या है, एंड वन मोर थिंग यू विल लर्न, वो एक बता देता हूं, देयर इज वन मोर थिंग दैट वी विल लर्न व्हिच इज नोन एज पल्स। अ पल्स इज अ सिंगल डिस्टर्बेंस। रस्सी खींचो, मी pulse, single disturbance, duck duck, that's the pulse na? When the blood is being pushed in your brachial artery, heart jab push karta hai, that's a pulse. Periodic motion, duck 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 duck, so it gives one pulse, 2 pulse, 3 pulse, 72 pulses. A pulse is a disturbance created, single disturbance wave. बस इसके बाद हम चैप्टर पढ़ेंगे। All okay? Anything that you want to ask, you can ask. So you should, when we study next time, because this chapter, whichever class you study, if you start to study it from what you call from the book, and you start what is mechanical wave, and कुछ समझ में नहीं आएगा। First you should understand wave mechanics. Wave होता क्या है, क्या चीज crest है, क्या trough है, what is frequency, then only you'll never need to memorize any formula. आप अपने आप समझोगे। Frequency, can you answer the question by looking at the graph? Can you calculate the frequency? By looking at the problem, can you calculate the frequency? And then all these things, identifying 2 graphs, which is a bachcha's cry, which is a bachcha ladki cry, which is a bachcha ladka cry. Shrillness, you know, right? Shrillness is dependent on pitch, pitch is dependent on frequency. मोर द फ्रीक्वेंसी, बच्चा गाना गाएगा तो हम लो स्केल में नहीं गाते, हाई स्केल में गाना गाते, बच्ची लड़की है तो, क्योंकि आवाज पतला है, बट द सुर विल बी द सेम ओनली, सुर में मेलोडी कोई गड़बड़ नहीं होगा, राइट? चलिए अगले क्लास में वी स्टार्ट विद आवर चैप्टर।